Hello all. Um, Today we will be taking this journey of exploring how current MedLLMs are working on our data, both as end users. It will be useful for healthcare enthusiasts, for practitioners. So my name is Kate. We'll be happy to take any questions on the go. So why why and how I get into the topic of medical LLMs. So my background is mostly computer vision for medical images. I came from academia, but currently I am leading teams in startups, healthcare startups. And my thing is robust models, which will not lose their accuracy with switching the domain. I really love to talk about MRI and brain MRI in particular, but today we will be focusing on medical LLMs. I am recently very active on LinkedIn, so consider connecting with me and we'll be very happy to be connected. Okay, so today's journey, I'm taking you with the journey of my sensitive data and how it will flow over the internet. I pick up the example very relevant to me. The example is as follows. So I've been feeling a fatigue and I have my blood count down. Can you please help me? I'm asking MedLLM, Claude, DeepSeek, you name it. If you see anything in my blood work that could explain my symptoms. So how we will spend next 30 minutes. We will do a real experiment on my data. I will be your guinea pig. We will check what accuracy to expect from the result, if it's safe to put my data somewhere in the web, and how to improve the result, and can we really improve the result? So it was a lot of questions that I have in the beginning, and I think I came up with something interesting, and I will be sharing this in the very end, so stay tuned. And please bear with me. I will be showing lots of tables in between, but I will do a spoiler alert for you, so you will know when you can skip some technical details. Okay, experiment number 1, baseline. As I said, I am asking, in here, I'm asking ChatGPT, default ChatGPT, look, I'm feeling fatigued. Here are my blood samples, what you can refer from them. I have attached 3 photos of my blood count tests from different years, different quality. You can see some of them are PDF, some of them are photos, and ChatGPT was immediately there to tell me what's wrong with me. It is photos, different quality, different languages, no prompt, and I'm testing 3 models, DeepSeek, Claude, and ChatGPT. Why? Because these 3 guys are the most popular among typical users. So all 3, just out of the box, was here for me to give me findings. But okay, what should I do with their results? Like, which one I pick? What is the accuracy? What do I expect any accuracy here? I actually did a little fun example, and I calculated the cost of the proposed additional tests that each and every model was suggesting me to take to confirm the symptoms or confirm the diagnosis. So ChatGPT will be costing me something like $500 to confirm what he proposed. DeepSeek is the most humble one. It will cost me only $100, $200, and Claude's in the middle. So it's actually not only a question which one I believe, but also where to stop, because it's my own money. I don't want to really spend it on nothing, on some hallucinations. So here we will take a little detour on what's happened in medical LLMs past months. We'll go through benchmarks and we'll get some numbers, like how to compare these guys. Benchmarks here, just bear with me. Here we will understand how do we as a community, as a scientific community, and industry as well, how do we compare and what the comparison of these models on medical data looks like. Okay, so it will be 4 of them. First, OpenBioLLM is the first known. Spoiler, it's already almost dead. Med-HALT is the most comprehensive. HealthBench from OpenAI, the first major commercial benchmark, and MEDIC. We will finish with this because it's the most actively developed. So OpenBioLLM, this is the first big benchmark that showed us that models like Llama is already good for tasks like medical question answering. Relatively good, 75. On the next slide, we will see how it advanced on more recent models like OpenAI ones. But you see the scores for different tasks and for different datasets are kind of high. And here we are jumping already for the most comprehensive benchmark. And here I want to point you on the hardest task, which is at the moment, which is computational reasoning. So to be precise in numbers and not just in question answering. Speaking of question answering, if you can see my mouse, it is at the moment it's already saturated with recent models. They know how to answer by the handbooks. Okay. So what is the current state? And this is the last benchmark. And this slide is actually the most up-to-date result with the comparison. And this is the most expensive slide I could imagine, because on the same slide, on last iteration, Stanford, which is responsible for Med-HALT, spent $38,000 on the API calls. So this costs enormous money to just test. We see that OpenAI O3 model, with the weighted average over 35 different tests, including this question answering and computational reasoning, O3 model currently is by far the most accurate model there is, followed by DeepSeek, then followed by ChatGPT 4o and Claude. So, okay, we remember that O3 on the most comprehensive benchmark is one of the most accurate. So it was confirmed previously a month ago by OpenAI themselves. They took different models, they took Grok and Gemini, and they showed that O3 is actually, watch my hands, almost 2 times more accurate than default 4o than I was using in my experiment. So this is the HealthBench, the data set that composed of over 5,000 conversations with physicians, and it was assessed by physicians with 7 different categories. by emergency referrals, response death, health data tasks, and this is not the typical QA as was used previously in previous benchmarks. Here we deal with the real conversations, and what is important, OpenAI showing us that indeed O3 model is by far the smartest there for medical data in real applications. They also show us that even O3 is very bad and context seeking, and this is something lacking in all models. So even though these models are performing, by the way, they are performing as good as weighted average physician, they're still lagging behind with the context and don't know what to ask you additionally. They will just generate output straight away. So last thing, and we will finish with this part, is that ChatGPT 4.1, which is not even 0.3, but it's one of the family of OpenAI, which is the current mostly used model. You see these red triangles on the different tasks like emergency referrals, health data task, global health, and blah, blah, blah. So you see that the weighted of several dozen physicians, like 40 physicians, 66 and whatsoever. So first of all, you can see how dispersed the responses of physicians from the weighted answer. So it is actually a good thing that OpenAI is showing us what is happening in the reality, how physicians from different countries globally diverge from each other. And basically, it's showing us that ChatGPT 4.1 is good as the weighted physician, but it really lagging behind in the context seeking. Okay. So we will finish with MEDIC benchmark. Here I just wanted to show you that this HealthBench that I just showed you was integrated inside the open source benchmark. Apparently HealthBench is a commercial one, so we don't know, we cannot reproduce it with pre-training and open models, but it was integrated in MEDIC, and it was shown that Qwen 3 is actually from open models that can be fine-tuned. It performs quite the best, but still much worse than O3. Okay, and here I don't have a funny picture, but the question here, so what? How accurate was my prediction? Like, do I really know if all my data that I sent was taken to action? Do I really know if it was hallucinating or not? Like, I know the accuracy. I know that I probably should put it into ChatGPT 03 by today, but I don't really know what to do. And moreover, I have a call. My insurance company is calling me at the moment to say that they will increase the cost of my insurance next year without actually explaining me why. But I can imagine that this is happening because I put my data in all over the internet. So here is a part about digital hygiene. There are already cases when somebody can steal your medical personality, yada, yada, yada. But I want to tell you about the closest example. Then insurance companies will be using our data more and more, and they can potentially use it. And if you're using DeepSeek frequently, be sure that you are not putting any sensitive data over there. And in OpenAI, as a default setting, you are sharing your data with the community to help the models to get better. So be sure to use to switch it off. It could be done, and keep your data safe. Yeah. So now we know that we not only now we know that we don't know. We know that the best models are DeepSeek, Claude, and ChatGPT o3 at the moment. But how do I know that my exact prediction is great? And here it comes with the art of prompt engineering. So with and without prompts, MedLLMs today can do great in artificial scenarios like handbooks. Most of them, like you can take it as a solved problem. But how do we know, and how do we estimate the accuracy in real life scenarios? One of the best examples for me to study how to improve, fine-tune, use RAG prompt for MedLLMs was to explore medical triage. Medical triage is the task when you need to estimate the severity of the case, of the symptoms, given the information that you have. And for medical triage and for EIC triage, we have lots of data sets and studies over there. So the EIC triage here is it's situated in the emergency rooms. The person is coming with his symptoms, and it's given the rank from 1 to 5. 1 is the most severe, 2 and 3 are still high risk, but it's needed to be decided by the needed resources like imaging, and 4 and 5 are stable, no resources needed for them. So the problem here is that the most of patients will not come with severe symptoms. They are very obvious. And these stable ones, which are with mild symptoms, they are also obvious. The most of the population will come to emergency room with ranking 2 or 3, and nurse should immediately classify them and put them in the queue according to their symptoms. And here is the big effectiveness gap. Some studies says that nurses can be mistaken in 40% when classifying 2 out of 3. And also it's very important to remember about edge cases. So here we have lots of good papers, and bear with me. We will see what these numbers really mean and how we can improve given models. So this study is done over ChatGPT 4o. It shows that here it's interesting column. It shows that the accuracy of the nurse is 64, doctor is 81, and ChatGPT 4o is 88, or given the dataset. But this dataset is kind of nice and pretty. And I like this study more because it combines several datasets. So it is not showing us accuracy of 88 anymore, but it shows how this Kate here means RAG scenario with prompting, how it can boost ChatGPT 4o with RAG and with right prompting from 0.5 to 0.7. And I think this is the good example of how in every particular case we can improve the accuracy. So in my case, then I am feeding the network my CBC results. I can, first of all, make sure I'm using the most advanced model, but also I can ask for chain of thought. It's kind of included there because all of the good models now are chain of thought. I can use design prompt and few shot or RAG prompt, but because I don't have any RAG for other CBC results and their diagnosis, I will just bear with prompt engineering. So here I'm just showing that for the same triage, the equivalent in chat scenario is emergency referrals, and actually this is the most accurate classifier in HealthBench. Okay. So next thing, how do I know? I know now how to improve accuracy. How do I know that there is as little as possible hallucinations, and how many hallucinations on the medical data are expected from ChatGPT? The good thing is that thanks for this brilliant paper published recently, like last month, we know that there is not much of a hallucinations, and most of them are they are not catastrophic. So you can see by the risk severity, they're still not zero. We want on medical applications hallucination rate to be zero, but the good thing is that we know how to eliminate them. First, we can use the mitigation strategy. So we can do test retest, we can do chain of thought, we can do some tricks, but just a nice prompting, mitigation prompt can really help us here. Missed data. How do we know that the photo that I fed the model was correctly recognized, like how good current models are as OCRs? So quite good. Again, 3% of omitted data, which is not ideal, but still could be mitigated with test retest. Last thing, which is not applicable here, but I will just briefly mention what will happen if I will put my radiology data like chest x-ray or something into Med-HALT. And I found that actually Med-HALT currently is not state-of-the-art if we compare to model specialist. So it's just a sad slide that I composed to tell you not to be hurried to put your MRIs or whatever models into VLMs, because MedLLMs, they still need to be there. There is no single LLM registered at the moment, and this is not a medical device in any case, in any sense, and they are designed to simulate the answer that we want to receive. So this is a disclaimer, and here is the fun part. Given everything that I said, what is the recipe for the best result in your specific case? Disclaimer, don't treat it as a diagnosis. It is not. It is just a tool for summarization. Maybe preparing you to see your doctor. So first of all, what you need to do is to feed your data into the model in safe way. And you need to transfer all your photos to JSON firstly, because it will help you to increase the missing data rate, so to decrease the missing data rate. So you do really want to care about the format of the data that you are feeding your MedLLM with, because it can really like even commas and spaces will change your, here is the result from Triage study. I think it's amazing experiment showing us that even serialization of the data is important. So second of all, the same study showing us that given the same input, native Hawaiian compared to white men somehow differed in the acuity of their symptoms. So given the this sensitive data, you want to omit it because it can really change the prediction, and you don't want it. So my approach was to convert everything to JSON, translate everything to English, and remove sensitive information. Wow. Somehow it doesn't work, but you know this picture already. It's HealthBench, showing you that you want to take O3 model to your experiments from ChatGPT, because you can switch off data sharing, you can turn off the temporary chat mode, and this is like the safest will be to run it locally. But given that the state-of-the-art model is still only accessible with API, this is the compromise that I went with. I'm not sure, like it should be your decision. It's not safe absolutely until it's run locally, but to run it locally, you will lose some of the accuracy, and you will need to compromise on the data size and whatever. So use prompting. Thanks for this nice papers I was mentioning. You can reduce this number of hallucinations. We remember that there are up to 2 or 3% of them to really below 1%. And important thing is what should be in the prompt. Then you converted your data from like into JSON format. You want to use prompting, and I highly recommend going through the paper, because I was following the thought process and experiment design of the authors, and it doesn't really, so it seems like it should be performing accurately with the first prompt, but they showed that prompt should be designed to be really effective. And it is still working to threaten your model that it can cause harm to patient. Mitigation prompt from other paper, but in a nutshell, the recipe for your data could be summarized as disable data usage if you're using ChatGPT, refresh it, open temporary chat, select any model. They are all good for scribing. Do, I would say, every document one by one, then close it, open another chat, and then select the O3 model, which is the smartest one. And here you can talk to your medical twin with the most accurate way. Yeah, I was, so of course I put everything in the Notion, which is available from the link, and you see the Atelic logo because I joined Atelic last week, and we will be doing we will be actually making these things real without the hassle with prompting. Yeah, so happy to share that I'm starting a new page in Italic and will be doing these solutions, hopefully available to everyone listening. So join waitlist, and that's it.
Fantastic. So we've got a couple of questions. I'll try to summarize them and get them all rounded up. So the first one, these two questions came at the beginning of your presentation when you were looking at the various benchmarks from Stanford, et cetera. Can you give a little bit of color on the sorts of questions that were asked of the LLMs during the benchmarks?
Yeah, sure. So, as I said, 35 different questions from questionnaires, and not only questionnaires. It spans from mental health handbooks or any other medical handbooks and guidelines to real data sets as like triage ones. Another important and is interesting thing is Med-HALT. So it's hallucinations dataset. So you can basically, you name it, all available data sets are tested in Med-HALT, from like just pick the right answer to write a text, and then another model as a judge is used to compare white book example to this particular case.
So another question was during the benchmarking section was, I don't know if this is a plug or if this is a question, but it's, have you tried the deep research model that asks questions back and finds the latest research to give a full diagnosis? So I suppose more of an informed question and answer as if you were having a virtual dialogue with a doctor.
Exactly. That is as I said, the main pitfall of all models that you will face as a default. They are not seeking a context. So you really want to prompt them to ask you back and gather all relevant information before they will be actually predicting anything. So yeah, make sure you are using deep search, or so it should be chain of thought. It should be prompted for context seeking. Yeah, check on the papers. I believe, yeah, first of all, I believe slides will be available, but prompts, there are good prompts over there, and they will help you with navigating these questions.
And we'll take two last questions. And the first one is, in your research and in your exploration, how much in the actual field, so I would suppose doctors' offices, clinics, and hospitals, are LLMs actually being used in production by doctors? So I guess from your presentation, I envision, are nurses in ER using this to help triage? Like, what is your take on the actual production use of LLMs in these settings?
By today, there is no MedLLM registered for clinical use as an agent, as whatever, for whatever automation, as a standalone device. None of them is actionable at the moment. So as a copilot, they are available as pilots, and they, like most of the big vendors, like Microsoft, AWS, blah blah blah, they all have healthcare branches, and they're piloting. A lot of pilots is happening here in UAE, in States, like a lot of things happens, but we are about to to understand actually what went good and what brought us to measurable outcomes. For now, we don't really know any public number, but what I want to say that a lot of doctors, they already, in practitioners, they already say that they are using ChatGPT already, because why not? Like, it's available. But here you saw the example of how just out of the box usage of ChatGPT could be hallucinative and could be Um, and DeepSeek also, it's just stealing your data. So please be aware of and caution about proper usage of these tools and keep the data safe.
Yeah, and I think what came to mind was your humorous picture of the self-medicating thing that kind of brings.
Exactly.
Um, so,
Exactly.
so let's take one last question before we get to Somaye's talk. Is in your explorations and in your research, have you found any noticeable differences in language? I would suppose English versus other languages in regards to the accuracy or the utility of the LLMs.
I did not. I did not see this exact thing in papers, but I can deduct from having this bias over nationality. I won't really risk. I will try because all these handbooks, all the major test data that we refer to is in English. I would rather be safe and just translate it in English. It's a simple task, could be solved easily with any model now.